Okay, we have interesting discussions going on today before we press record, but we'll focus back on these four questions. So we have a warm-up today of four inequalities. You're given one, you have to give the other, plus a valid set of numbers that would encompass that set. So the first one says twice a number is at least 10. So when we say twice a number, what we really mean is the idea of multiplying a variable by 2 or adding a coefficient of 2. So twice a number, algebraically, will be represented as 2x, is at least. Can it be 10? Yes, it can. So it has to be greater than or equal to 10, because at least 10 means it can be 10. I bet you a lot of you just had is greater than 10. That's the inequalities. That's the second one. And then a number line, 10 in the middle, 9 over here, 11 over here. We need a closed boundary point, and any number from that over would be a number greater than 10. Once we have that, we need a mini set of numbers that would be valid. So we use our little, that's not a very good bracket. There we go. Any number that would be valid. So 10 would be our first whole number, 11 and 12. There is a mini set of numbers that should be valid within that inequality. In our second question, we have a number line. The middle one's not numbered, but you're supposed to infer that that's 1.5. So all numbers less than 1.5 is a statement that would encompass what that says. All numbers less than 1.5. And from an inequality, all numbers less than 1.5 is our inequality. A set of numbers that would encompass. What's a number that's less than 1.5? Well, if I think of my first whole number, 1, 0, and -1 would be the first three integers that are less than 1.5. For our next one, it says half a number is greater than or equal to 4, or half a number is greater than or, that one there means what? Or equal to 4. So half a number is greater than or equal to 4. You could also say a number divided by 2 is greater than or equal to 4. Both are, of course, okay. Can't erase that little circle, but we'll just keep it there. In order to put it on a number line, you do have to solve it. So I'm going to multiply both sides by 2. And the solution will be this. So that's what I have to graph on my number line. So I have to take my number line, put 8 in the middle, put 9 over here, put 7 over here. All numbers greater than or equal is a closed boundary point, and all numbers greater than or equal to means my number line would go that way. And our last question is a double boundary, meaning we have a variable in the middle and we have two numbers that are going to be fence posts, if you will, or double boundaries. In order to read this properly, I want to read it this way first. I want to read it backwards from the variable to it. I'm going to read all numbers. That's the variable x, all numbers. That's what our x actually means, all numbers. All numbers, and if I read it backwards, all numbers greater than or equal to, because it's eating that all numbers. So all numbers greater than or equal to 4. But since it's a double, I'm going to use the word but with one T, not two. But less than, thank you very much. I'm here all week. 5. So a good sentence for that double inequality is all numbers that are greater than or equal to 4, but all numbers that are less than 5, or but less than 5, because we're still talking about all numbers. When we put that in a number line, 4 goes here, 5 goes here. All numbers greater than or equal to 4. What does that mean my boundary point is? It's going to be closed. And all numbers less than 5, it's an open boundary point on that end. And all of those are going to be valid numbers in the set. Oh, I forgot to do a set over here, didn't I? Okay, I'll come back to that. So our set of numbers that would be encompassed there would be 4, 4.1, and we'll go 4. I'm going to make up another one. I'm going 4.73 repeating. There's a good one. Why did I choose it? I don't know. Whatever. But those are 3 valid numbers. You would have different ones, of course. And over here, I forgot to give you this one. 8, 9, and 10 would be your valid set of numbers for that set.